All right, here we go. This is an opportunity for you to check your understanding. So please try this on your own first. Now, from the mind of the fifth grader, though, grab the virtual manipulatives, draw out some pictures, write some notes, whatever you think you need to do, but to have the experience of thinking through addition of fractions from the mind of an elementary age student. After you've done that, then come back and check your understanding against mine. Remember, the goal here isn't just about you being able to do this, but thinking about how we're going to develop the ways of thinking that will be productive for our kids. All right, pause the video, give it a go, and then come back and hear what I have to say. All right, first of all, notice here in this case, I specifically called out, together, did he use more than a half of a cup of flour? Now, the reason I call that out is if we have any students who are thinking, oh, a third and a fourth, well, I see a plus sign, I see four numbers, I'll just add and get 2/7. 2/7. Well, let's think about that and see if it makes any sense at all and start to develop some of that visual ability using the manipulatives. And so, using the manipulatives, first of all, what was it again? A third of a cup and a fourth of a cup. So a third is this piece, and a fourth is this piece. And so a third of a cup and a fourth of a cup, when put together, are clearly more than a half of a cup. Ah. Sorry, I don't want that to happen. Are clearly more than half a cup. Look, there's a half. We're clearly past a half. And so if we have students thinking about addition in this way, we can dispel that myth very quickly and say, does 2/7 even make sense? That 2/7 is less than a half. So maybe we can quickly eliminate this as an idea and focus more on this. We have a third of a cup and a fourth of a cup, and all together, so addition is the idea here, all together, how much flour was used? Clearly more than a half of a cup, we can see it. All right, but now, exactly how much is it? And this is where we have the dilemma, the intellectual need. It is challenging to add together this yellow piece with this orange piece. So this is where we allow students to try, to think, to reason. We don't tell them what to do. We don't tell them how to do it. We help them to think. We ask questions that help them to think. And so they might try splitting this up. Well, what if we used the blue pieces? And students might literally start to put these together and quickly realize that, that's not going to work. Now, it might have been good. It might have been helpful, but it's not perfect to get all the blue pieces. Yeah, there you go again. It works great here, but it's not going to work here. So blue's not going to cut it. Let's try something else. Let's try something else. Let's try something else. Maybe when you were playing with this, you had to play around a little bit to figure out how can we split this up into an addition problem so that it's clear to see how many pieces that we have. And I think what you're going to find is that the gray ones do it. And that might have been clear when you saw those two blue ones and there was that little piece left over. Come on. Look at that. Yeah, that's gonna do it, isn't it? So the yellow, which was the 1/4, is gonna take 3 of these things. Now, here's where the thinking comes in that you'll have to help the kids to do. Now, oh, you little bugger. Can you imagine a kid working this through and they find the gray piece is finally gonna work, but they they don't know what the gray piece is called maybe. So here's where some thinking might come in. All right, so the yellow was clearly a fourth. And 3 grays make a yellow. This might harken you back to some work that you did in a previous module. 3 grays equal a yellow. Well, if yellow's a fourth, and a fourth is what you get when you take a whole and cut it up into 4 equal pieces. 3 grays equal a yellow. So there's 3 grays, 3 grays, 3 grays, 3 grays, 3, 6, 9, 12. there's 12 grays in a full circle. And so each of those grays is a 1/12. And so this yellow piece, which was a fourth, is 3/12. And they may have found that if they work with the gray pieces, which, by the way, when I put those blue ones in there, you might have seen that gray one sticking in the middle there, and you're like, oh, it should have been the gray ones. And what we're going to see with the gray ones is that is that 4 of the gray ones will fit into this 1/3. You see it? Telling you the actual manipulatives on a desktop are so much easier to work with. Yeah, look at that thing. All right, so 3/12 and 4/12 is really how this all boils down to. And so instead of adding together a fourth and a third, what it really boiled down to is this: a third of a cup of flour plus a fourth of a cup of flour. And through some problem solving, through some things, we don't have to tell kids to do it. They just have to figure it out. They can see that with this 1/3, I took 4 gray pieces. Now, if you took 4 gray pieces and applied them to each of the thirds, 4, 8, 12, that would have been a total of 12 pieces to make the whole circle. And so 1/3, one copy of 1/3 is the same as 4 copies of 1/12. And with the 1/4, it took 3 of those gray pieces to fill in the yellow. And so for a whole cut up into 4 equal parts, each of those parts is a fourth, and each of those parts has 3 grays. So 3, 6, 9, 12. There's also 12 grays in a full circle there, and I had 3 of them. And so 4/12 plus 3/12. Now, here it comes again. If the kids are thinking about fraction in the cut and copy perspective and not just as 4 numbers, they're thinking 4 copies of 1/12, and they're connecting to what they see. We have 4 copies of 1/12. We have 3 copies of 1/12. And addition means to put all those pieces together. And when you put all those pieces together, you have 7 copies of 1/12. And I'll say it again, that when kids have been thinking this way, I have not seen a kid think, oh, I clearly should add the numerators and the denominators. And when they see it here, they see 3 grays and 4 grays. And 3 grays plus 4 grays is 7 grays. But what's a gray piece? It's a 12th. And so I have 7 copies of 1/12. I have 7 1/12s. I have 7 12s. So there it is in all of its thinking that we're going to see students do. Now, students are going to need repeated opportunities to think through this. They're going to have to practice this. We're going to have to formalize that. We're going to have to help them to see. And here's how I would want them to see it. When you add 1/3 plus 1/4, what we first do is we replace this. What we did is 1/3 plus 1/4 is the same as, that's what equals means, is the same as 4/12 plus 3/12. And you saw that in the picture because 1/3 and 4/12 were equivalent and 1/4 and 3/12 were equivalent. And that again becomes 7/12. So students start to learn how to express what they're seeing with their manipulatives. Now write it out. Write out what you're doing. How that 1/3 becomes a 4/12, how the 1/4 becomes a 3/12, and how combining those quantities together gives you 7/12. And they start to learn how to express their mathematics in this more abstract writing way. Now, one more thing about this is, I know you've probably learned the thing where you say, well, to make an equivalent fraction, you multiply by 4 over 4, and that gives you the 4/12. And I get that's an algorithm, but you've been learning a lot about the rushing to algorithms, and that's not really what we're doing here in terms of our thinking. I mean, it's mathematically correct, but it's not really how our thinking is connected. Our thinking was connected like this. We took a 1/4 and we further cut it up into 3 more pieces. So when you further cut up that 1/4 into 3 pieces, maybe I should just put this up here, huh? Maybe that would help. Just go up there then. If you want to be up there, then just go up there. Look at that. Hey, look at that. We just further cut it up into three pieces. And so now you can see what's happening, why the algorithm works. Is we first of all took the 1/4 and cut it up into three equal pieces. And then we did that for, imagine each of the fourths. Imagine all 4/4 getting cut up into 3 and 3 and 3 and 3. And so this gets times 3 times 3. Everything gets cut up into 3 more pieces. And now when you connect that back to the algorithm, we took 1/4, and first the numerator, that one copy of 1/4, got tripled because we cut it into 3 equal pieces. And then all 4 parts of the 1/4 each got split into 3 equal pieces. So got multiplied by 3. And now we can see the algorithm working. But I hope that if we have kids doing this algorithm, they can also explain the algorithm by taking them back to something like this and saying, hey, yeah, look, see those 3? There's 3 there, there's 3 there, there's 3 there. So there's 4 copies of 3. And then there's 1 copy of 3. The numerator is 1 copy of 3. The denominator is 4 copies of 3. So even if we have algorithms emerge in our teaching and learning, great, but those algorithms should be tightly connected to the experience. All of that to say, now, addition of fractions can be visual. Kids could eventually later on close their eyes and imagine, and we can start to ask questions like, should the answer be more than a half or less than a half? Or whatever. It doesn't have to be a half. A half is just a good benchmark, right? We can start with a half and see what side of a half we're on. And then that way we can dispel things that are untrue. We can make sense of things that are true. We can make sense of the equivalent fractions. And then, yeah, we can say, hey, when you add fractions, now this is coming at the end of the instruction. You can highlight that, yeah, when you add fractions, common denominators are really useful. Why are they really useful? They're really useful because when you make the pieces all the same color, when the 1/4 became 3/12, and when the 1/3 became 4/12, so I'm not going to put those in there nice, but when they were all the same color, then 1/4 plus 1/3 became 3/12 plus 4/12, which was clearly 7/12. Common denominators just make addition easy to see. So we start to formalize after the experiences. We start to formalize and help students to understand the mathematics behind it all. I'm going to stop there. Think about subtraction next.